Then the objective of this chapter is first, we discuss the functions of the IP protocol. Okay, and then we discuss the IP address. Okay, the IP address, the types. There's different types: the public, the private, and some special IP address. And then we discuss the VLSM. Okay, the variable length subnet mask, and then the function of IP gateway. And first, this is the Ethernet frame, the format of Ethernet frame that we have discussed in the previous chapter. Okay, in this Ethernet frame, we can see this format is Ether2. Okay, the first two fields is the destination MAC address and the source MAC address. Okay, the MAC address is a layer 2 address. It is used for the destination search, okay, to identify the source and destination in the local network, local area network, LAN, in the LAN. Okay, and then the end field is the FCS, the frame checksum, to check if the frame is not destroyed during the sending from the source to the destination. Okay, and then, as we know, this is the layer 3 protocol. The data presents the layer 3 protocol. And as we know, in the layer 3 protocol, there are many different types, such as the IP, IPX, and others such as ARP, and so on. Okay, then how to identify what is the protocol contained in the layer 3? Okay, we use the type. This type field is the Ether2's third field. Okay, this field, if the value is 0800, just point out this is an IP packet. Okay, then what is contained in the IP packet? You can see. Yeah, this is the IP packet. Of course, this is contained in the layer 2 frame. Okay, the frame. Okay, this is the FCS, and this is the type. Of course, before the type, there is the destination MAC address and the source MAC address. Okay, then this is the layer 3 packet, and in the layer 3 packet, there's first is the IP header. Okay, and then the data. Of course, this data is the layer 4. That's the layer 4 segment. Okay, layer 4 segment. And then what is contained in the IP header? Of course, there are many fields. And we can see the field of the IP header is divided into two parts. First is the fixed header, and then another is a variable. This is IP options, not exist in each IP packet, but the fixed header exists in each IP packet. Okay, the fixed header is 20 bytes long, and the IP options may be variable. That's from 0 to 40, and at the total, the whole is 20 to 60 bytes long, the IP header. Okay, but usually what we see in the IP header is a fixed IP header. Okay, then there's many fields exist in the IP header, and then most important is the IP address. This IP address just to identify who is the source of this packet and who is the destination of this packet. Of course, there are many other fields we will discuss later. Okay. And then the IP addressing. And the IP addressing is a 32-bit long value, 32-bit. Okay, this is a binary. Okay, 32-bit. And this IP address is divided into two parts. Okay, the one part is the network part, and another part is the host part. The network part just to identify what network is this IP address, is this host exist. Okay, then the host means in this network the host number. Okay, as we know, the network is organized as this. There's a one network and there's another network. Okay, each network must have a network number. Okay, maybe this is 192.168.1. Okay, and then this may be 192.168.2. Okay, these are different network. Okay, they must use different network numbers, and then for each host in this network must have different host numbers. Maybe this is .1 and maybe this is .2, and then that's .1 and .2, and then here also .1 and .2, and then these two parts combined together then form the IP address of one device, one host. Okay, and yeah, the IP address identify networks. This is a network part, and the network host. This is a host part. Okay, and then in the computer we use a binary. And then in this number, this is the IP address we usually write in the for our human beings to see. This is the decimal format. Yeah, this is a decimal format. And then in the IP address, there's some special values. Yeah. Now this network, this is a network number. Okay, and the host number we can see there's different values, but two special values we cannot use to assign to host. Okay, one is 0. Okay, when the host part is 0 means this is a network number, network address. Okay, this IP address is used to identify the network, not used to identify the host. Okay, this represents the whole network. Okay, include all the hosts contained in this network. Okay, and then another address is a broadcast address. The broadcast address, the special value is the host value. It's all ones. All ones. This value also cannot assign to a host. Okay, this represented by all the hosts in this network. Of course, this network cannot assign to host, but this address can only exist in the destination IP address in IP packet. In the IP header, there's a source IP address, destination IP address. Then this address can only exist in the destination IP address. When the packet using this address as a destination IP address, then this packet should be received by all the hosts in this network. Okay, this is the broadcast address. Okay, and then we discuss some background knowledge of the decimal, binary, and hexadecimal. Okay, in a computer, we use a binary. The binary means there's only two values, 0 and 1. If you want to represent 2, then how to express this? That's 1 0. Okay, 1 0 represents 2. If you want to represent 3, then 1 1. Okay, this 1 means 2. Okay, and then the decimal. Okay, the decimal is we daily used. Okay, that's the value is from 0 to 9, and then if it's 10, then you write as a 1 0. Okay, this is a 10, and 11. Okay, that's 12. Okay, that's the 13. Okay, and the hexadecimal. The hexadecimal is another form of the binary. Okay, one character in the hexadecimal represented 4 characters in the binary. For example, this is the 0 and then to 9, and then 10 represented by A, 11 B, C, D, E, F. F means 15. Okay, means 15. And then the 15 in the binary just the 1 1 1 1. Okay, that's the 4 characters. E means 1 1 1 0. Okay, this is in binary. Okay, in binary. That's the 4 characters just represented 1 character in 4 characters in binary just represents the 1 character in hexadecimal. Okay, that's the 16. The base value is 16. The 1 0 in the hexadecimal means 16 in the decimal. Okay, this is the hexadecimal. Okay, in the computer, we usually in the computer truly it's used binary, but for our writing, we use the hexadecimal to abbreviate the expression. Okay, and then in the address, we use 32-bit. Okay, 32-bit to binary bit. Okay, and then we can divide this 32 into 4 parts. Each part is 8-bit. This is just 1 byte. 1 byte. Okay, and the 1 byte have 8 bits. This is the 1 byte. And in this 1 byte, each bit represents different values. Okay, what is the value? This one, the last one, is 2 powers 0, and the second is the 2 powers 1. Then the third 2 powers 2, and then so on. That's the 2 powers 7. Okay, in the decimal value, 2 powers 7 means 128, and then this 2 powers 6 means 64. Okay, we can calculate this each bit value. Okay, and then we can count. For example, we have a value such as this value. We can see that's the 1 1 means this is 1, this is 1, and then all the others is 0, and then this is 1 and this is 1. That means 2 plus 1. Okay, that's the 3. Okay, that's the 3. And of course, in decimal it's 3, but in hexadecimal it's also the 3. Okay, and the hexadecimal, that's the 1 character in hexadecimal represents the 4. Okay, represents the 4, and then we can see, yeah, from 1 to 8, that's the 1 0 0 0. That means 8. Okay, means 8. 1 0 0 0. Okay, and all the others are 0, and then just 8. And then 1 0 0 1. That means 8 plus this value, and the 1. That's the 9. Okay, and then this is a 10. Decimal, in this decimal it's 10, but in hexadecimal we can see this is the A, and then 11 means B. Okay, and then so on. Okay, this is the conversion. Okay, from the decimal, binary, and hexadecimal. Okay, the value that's equal. Okay, in one row that's equal, but in different expression. Okay, and then in the IP address, for example, this is the IP address. The IP address have 4 bytes, and then in here, the 3 bytes are network part, and 1 byte are host part. And then, how to calculate this? We can see this is 2 power 7, and then plus 2 power 6. And then we can calculate this is 192. Okay, 192. And then this is 7 and 2 power 5, and then 2 power 3. And then the result is 168. Okay, this is a 1, 1. Okay, so the binary IP is as this, and then the calculated decimal IP address is as this. Okay, you're better to practice and then know how to count between the binary and the decimal. Okay. We go back to the IP address. The IP address now we know is divided into 2 parts: the network part and the host part. And how long is the network part and how long is the host part? How to decide it? Okay, originally, at the first, they are standard to divide the network into different types, different classes. The class A and the class B and the class C. Of course, there's another 2 class, okay, for special use. And class A says the network part is 8-bit long, 8-bit long. And then, what is the class A? The class A means the first binary number is 0. That means the first byte in first byte, this is 0. And then the rest 7 bits should choose any values. So the smallest value is the 0, okay? And then the biggest is 127, okay? But there are some special network parts. For example, the 0 network is used for special purpose. So, and 127 is also used for special purpose. So, the range is from 1 to 126. Okay, this is the range. If the network is among this range, then the network mask is always 8. Okay, and then another thing, the class B is beginning by 10. The 10 means the 10, and then the rest 6 bits can choose any value. So we can calculate the range is from this 128 to 191. Okay, so this network range, okay, we can decide the network mask length is 16. Okay, and the class C, the range is begin with the binary of 110. Okay, then we can calculate the range is from 192 to 223. Okay, and this mask should be 24. Okay, this is the original rule to decide the mask length. We can see the first byte, the value of the first byte of the IP address, then decide what is the mask length of this address. Okay, this is the class ABC. Okay, the class ABC IP address can be configured on the host. Okay, to identify this host. And then there are two other class. First is the class D. Class D is used for multicast. Okay, yeah, this address cannot configure statically on a host. Okay, this is used dynamically. Okay, and then the class E. This address is reserved. Yeah, used for experimental. Okay, not exist in our network, in the internet network. Okay, this is the IP address class. Okay, then we have discussed some special address. Okay, such as 0000. Okay, this address you cannot use to configure on the host. This represents the any network. Okay, and the other special address is 127. Yeah, this address also you cannot configure, but this address exists in the device that's running IP. This address is we call loopback address. That means if you enable the IP in one device, then this address exists. If you send the packet to this address, then this address will not sending out of the NIC, network interface card. This address is looped back. Then what you're sending out, then this packet loop back to the source. Okay, of course to itself. Okay, this is a loopback address, and then there's a broadcast address. These broadcast addresses are all ones. In the previous, we use such address 192.168.1.255. This is the host part of this address is all ones. This is also a broadcast. And 255, all ones, the 32 bits are all ones, is also a broadcast. This broadcast we call local network broadcast. Yeah, this broadcast cannot send to other networks, can only send in the network local to the sender. Okay, and this broadcast can sending from one network to other network. Okay, for example, the source is 192.68.2.1. Okay, this is the sender. Then sending out a broadcast. This broadcast is sending to another network. Okay, this is the some special network address. And there's another type of special network address we call the private address. Okay, the private address means this IP address cannot configured in a network that's connected to the internet. Yeah, internet, the global network, global IP network, the internet. Okay, this IP address cannot configure on any device connected to internet, but you can connect to a device that's local to your company. Yeah, in the campus network that's not connected to the internet. Okay, and the IETF have defined three range of the private IP address. The first is the class A IP address. It's the 10.0.0.0 to 10.555, 10.255. And then the class B, the range is from 172.16 to 172.31. Okay, this is the class B. Of course, the class B default mask is 16. In the class A, the default network mask is 8. In the class C, the default network mask is 24. Okay, and the range is 192.168.00 to 192.168.255.255. Okay, this address range, this three address range is used for private use. That means you can configure on your network that is separated from the internet. Okay, and then the IP communication. When the PCs, when the host wants to communicate with other host, with another host, the PC first should decide what is the destination located. Okay, if the destination IP address and the IP address, the network part is the same as the sender's network part, then that means these two hosts exist in the same network. So the hosts can send direct to the destination, send the packet direct to the destination. But if the sender wants to send in to the destination that have different network types, here, the network type, the network address are different from the source, then the source will not send to the destination. Okay, the source will find the gateway. For example, if you deploy a router in between these two networks, then this address is the gateway. Then the source will send in the packet to the gateway. Okay, then the gateway will searching in the routing table and then sending to the destination. Okay, the different network parts, the IP address, the different network parts, you cannot, of course, you can configure into devices that connect in one network, yeah, but they cannot communicate. They cannot communicate. For example, this is .1.1 and this is .2.1. They cannot communicate, okay? Because they regard them are separated in different network segments, okay? And then we go to the subnet mask. In the class A, class B, class C system, we did not use the network mask. That means if you see address that's the 192, then this number you can decide this is the class C. Then you can decide the mask length is 24. Okay, the mask length 24 means the network part is 24 bit long and the host part is 8 bit long. Okay, this is the default network mask. But how to represent? We can use the network mask. The network mask is divided into two parts. one part is a series of ones, and another part is a series of zeros. The ones part means to identify in this IP address, the ones part are network part, And the zero part are host part. Then, use the network mask. We can divide the network IP address into two parts, the network part and the host part. So, by default, the class A, class B, and class C have a default subnet mask. As we know, in the class A, the first 8 bits are network parts. So, the mask for the class A should be as this, 255 and then .0.0.0. Okay, and then the class B, as we know, the class B, there's 16 bits used for the network part. Okay, so the network mask for class B should be 255, 255, and 0 and 0. Okay, and for the class C, there's 24 bits used for the network part. So the class C, the mask should be 255, 255, and 255.0. Okay, this is the network mask, the default network mask for class A, class B, and class C. Okay, and then we can see the address plane. For example, now we got the IP address and the subnet mask. This is the IP address 190, 192, and 168 and .1.7. Okay, then this is the mask. The mask said there's 24 bits. Yeah, the first 3 bytes used for network identification, and the last 1 byte is used for host. Okay, and then we can see this part is the network. Okay, when the host part is all zeros, we know that all zeros is a special IP address. This IP address is represent the network as a whole. Okay, the network as a whole. So this is the network address. This is a network address. Okay, then the host part, we have 1 byte. That means the host part there's 8 bits long. The 8 bits long. So how many IP address, how many values can this part represent? Okay, we can see this is 2 powers 8. So the value should be 255 values from 0 to 255. Okay, that's the 256 values. But as we know, all these values, there are 2 specials. That all 0 value is represented the network as a whole. Okay, so this value cannot configure on the host. Okay, and the 255, that's the all ones value. All ones value we have discussed, it's represented the broadcast. Okay, so this value also cannot be configured on the host. So how many values can be configured as the IP address on the host? That's the 2 powers n. That's the 8. Okay, 2 powers 8 minus 2. So the valid IP address that can be configured on the host is the 254. Okay, this is how to calculate the available IP address in the network when provided by the IP address and the subnet mask. Okay. Then we got a case to identify, to practice. Okay, this is the IP address and this is the subnet mask. And we know now this is the subnet mask divides the IP address into two parts. This is the network part. This is a network part. And there are 16 2 bytes, there are 16 bit long, okay? 16 bit long. And the host part, also there are 16 bit long, okay? And then, what is the network address? Network address means the host part are all zeros. So the network address is 172 and then 16 and then 0 and 0. Okay, and then the host address, how many values can this choose? Okay, and then that's the 2 powers 16. Okay, 2 powers 16. Okay, just that's the 6, 5, 5, and 35. Okay, and how many addresses can be used? Okay, yeah, the range is 6. Okay, 2, 6, 5, 5, 3, 6. Okay, this is all the values. The range is from 0 to 6, 5, 5, 3, 5. Okay, this is the numbers of value that's included in this range. Okay, 2 bytes, 16 bit. Okay, and then the varied means the 0 cannot be used, and then all ones also cannot be used. So the varied IP address can be configured on the host is 6, 5, 5, 3, 4. Okay, this is the number of IP addresses that can be configured on the host included in this network. Okay, this is the class ABC system. It can work, but there are some shortcomings. What's the shortcomings? For example, the class A, the network part is the 8-bit. Okay, so the host part is the 24-bit. 24-bit for host. So how many IP addresses can contain 2 powers 24? Yeah, this is a bigger number. Okay, this is a bigger number, about 16 million. 16 million. I think no network can contain so many hosts in one network segment. Okay, and of course the class B also the network mask is 16. So how many hosts can contain 2 powers 16? So about 64 kilo. Okay, 64 kilo hosts in one network. That's still too many hosts. Okay, so this is the example. That's one in such network. One network contains 30 hosts. Of course, the smallest one, class C, can contain 264 hosts. Okay, that's still too many IP addresses. If we use class C, then about 200 IP address is wasted, not used. So how can we solve this problem? We have use the mask of 8, use the mask of 16, use the mask of 24. If we can use other masks such as 20, such as 27 and 28 and so on, can we use this? Okay, this is a question. Okay, so we developed another system we called VLSM. Yeah, variable length subnet mask. That means the mask length is not fixed. Is not fixed to 8, 16, and 24. Okay, the network mask can be variable. Okay, here you can see this is the network address. Okay, and then this is a subnet mask. This subnet mask is different from the class A, class B, and class C. That's a 255, 255, and 255. And then this is not 0. This is 128. We can see 128 represents the first one, and then others 7 is 0. Then we can see in this mask the 25 are a sequence of ones, and then the 7 are 0. Okay, that means the 25 bit in this 32 bit are network part, and the 7 bit are host part. And then we can see the network part is the network address is 192.168.1. And here the host part are all 0, and then the first bit network part are all 0, are still 0, are also 0. So the network part is 0. And then how many hosts can contain in the host in this network? That's the 7 bit. Okay, then 2 power 7. 2 power 7 is the 128. Okay, of course, the varied host, that means this address includes the 0 and the 1s, all 1s, all 0s. All 0s represent the network address, and all 1s represent the broadcast address. So minus 2. Then this is the varied IP address can be used in this network. Yeah, it's the 126. Okay. Then this is the case how to calculate the VLSM. Then we just calculate it. There's 30. Okay, in the first network there's 30 hosts. 30 hosts. We first calculate 2 powers n should be greater than or equal to 30 hosts, because in the network there's 2 IP addresses cannot be used, all 0 and all 1s. So this is 32. 32 just equals 2 powers 5. That means in the 32 IP address there's 5 bit. 5 bit should reserve for the host part, and then the other 27, okay, 27 bits can use for the network. Okay, 27 plus 5 just equal 32. Okay, equals 32. Okay, so the IP address, the network mask should be 27 length. Okay, the length should be 27. Of course, the value should be 255.255.255. Then 27 means what? 224. Okay, 224. 27 means 111, then 50. Okay, this is a binary value. If you calculate it, just equals 224, 224. Okay, and then we calculate another. And another network contains 20 hosts. 20 hosts, you calculate 2 powers n should be greater than or equal to 20 hosts plus 2. Okay, that's a 22. That's 22. Okay, if you n equals 4, that's the 16. That's smaller than 22. If it's 5, it's 32. Then greater equal 22. Okay, and then if it's 32, okay, just equal the first case. There contains 30 hosts. Okay, so the mask of these two networks should be the same. And then if they contain 10 hosts, so also we calculate as this: 2n is greater than or equal 10 plus 2. Okay, to resolve the IP address, that's 20. That's 12. And then n should equal 4. Okay, then in this 32 IP address, the 4 should be reserved for host part. So there's 28 bits used for network. So the mask length should be 28. Then we can calculate the mask should be 255, 255, and 255. That's the 24 bit. And then the last bit, that's the 1, 1, 1, 1, and then 0, 0, 0, 0. We can calculate the binary. Then that equals 2, 4, 0. Okay, you can practice this. Okay, this is how to calculate the VLSM. Okay, and then another concept of the classless inter-domain routing. There's the abbreviation. That's the CIDR. What's the CIDR? Yeah, when we use the class A, class B, class C address, then the route sending by the router always have the mask length of the 8, of the 16, of the 24. But now we use the VLSM. Okay, the mask length is not always equal these three values. So the router should send in route of different mask lengths. Maybe sometimes that's 27. Sometimes that's 20. That's 20. Okay. For example, in here, in this scenario, there's 4 networks. 4 networks. Of course, the first 2 bytes is the same. The same. Of course, the last, of course, is the host part. Host part, of course, when we use a network address, it's always 0. But the third byte is different. 0 means 0, 0, 0, 0, and then 0, 0, 0, 0. And then 1 means 0, 0, 0, 0, and 0, 0, 0, 1. and the 2 means 40, and then 0010, and then 3 means 0000 and 0011. Okay, we can see the third byte, the first 6 bits is the same, our 0, and the only last 2 bits are different. Then we can summarize sending one network mask. That means there's 16 bits is the same, and then additional 6 bits is the same, our zeros, and then others is different. So we use this 16 plus 6, that means 22. 22, the first 22 bits are 10, 24, and then 0. And then the rest 10 bits include the last host part and the 2 bits in the network part. That's the variable. Okay, so in here, this router sending out a route, one route, that's value is equal this. The mask length is 22. Okay, this is the CIDR. The CIDR can make a routing table small. Okay, the 4 routes, 4 networks, then only sending out one route item. Okay, this is CIDR. In the previous, we have discussed this is one network. Of course, the mask length is 24. Okay, when 2 computers connect together, okay, if you want these 2 computers to communicate each other, they first should be exist in the same network. Okay, if in the same network, then the computer will sending packet. In the IP header, the source IP address should be itself, and the destination IP address should be this destination IP address. And if these 2 computers that not exist in one network, here, this example, these 2 computers just not in one network, then how do they construct the packet? First, the source IP, of course, itself, and the destination IP, still this computer. But when this packet sending out, this host must know the destination IP is not exist in the same network. So this computer, host A, first we are searching for the gateway. The gateway is the exit point of this network, just as the door of this room. Okay, one network just as one room, and then this is as a door exit point, and of course this is another network, of course just as another room. And then when one package in one network segment wanted to another segment, should go to the door. That's the gateway. And then the router receiving this packet and then seeing in the destination IP, that's destination IP is this address, and then searching the routing table and then seeing this address is this interface. Then the router will sending the packet out of this interface. Then the host B will receive it. This is the concept of gateway. Okay, if there's no gateway, the computers must configure use IP address with the same network part. Okay, they are in same network, they can communicate. If two computers configure IP address with different network parts, they cannot communicate. The computer will searching for the gateway. Okay. And then the IP headers. This is the IP headers. Okay, IP headers. This is the fixed part, and this is the option part. We have discussed the IP address detailedly. Okay, IP address detailedly. And then there are many other fields. Many other fields we will discuss later. First, the versions. Of course, the IP packet is IP nowadays is IP version 4. Okay, and the header length, that's because there are the options. So the length should be 20 to 60. So you need to figure out what is the length of the header. Of course, usually it's 20. The DS field, DS means differentiated service. This is used to identify the grade of this packet. Okay, what is the preference of this packet? And the total length. The total length means the packet length includes the header and the data, the upper layer data. Okay, upper layer data. And then we go to the grade part. Okay, the identification fragment and the fragment offset. What is it used for? This is used for packet fragmentation. Fragmentation. What means the fragmentation? Fragmentation means the host A, when the host A sending out one packet, but when the router sending to another network segment, in the previous chapter, in the Ethernet chapter, we know there is a concept of MTU, the maximum transmit unit. That means how long can a frame sending in this network? For example, in this network, maybe the 1,500 packet frame can send, but maybe in this network only 1,000 frame can send. So if the host A is sending out a 1,500 frame out, then the router should fragment this packet into different packets, into more than one packet. One is contained 1,000 and another contains 500. And then this packet can go to the destination. Okay, if the fragmentation happened, we need to the field to identify the fragmentation is happened, and then what is the sequence of each fragmentation. Okay, each fragment. Okay, then the identification is to identify these two fragmentation is in the same packet. It's the same packet. And the fragment to identify if the fragmentation is happened in the sequence. This is the first, and this is the last. Okay, this is the last. Okay, and fragmentation offset means the first fragment, the offset is 0. Okay, this is the first byte in the packet, and the fragmentation of this is 1001. Okay, this is the offset is 1001. Okay, this is this three field used for fragmentation, and we should know how this field identify the fragmentation, and then the receiver can use this field to reassemble this fragment. Okay, this is the IP fragmentation, and then another field, the TTL. That's the time to live. What's the time to live? Time to live just to count how many hops. Hops just means routers. How many hops the packet have passed. For example, when the hot A sending out, the TTL use 8 bit. Okay, so the TTL, the maximum value is 255. And then when this packet passed one router, and then this value will -1. And then this is 254. And then another -1 again. Okay, and until if there's many routers, and then until the TTL reach 0, then this packet will be dropped, not forward again. Of course, nowadays there's no such networks that have more than 200 hops away, but maybe we will encounter such a scenario that the network is looped. That means the packet will forward between the routers again and again. Okay, this is the looped. Okay, that's loop means the packet will going through these routers recursively. Okay, never stopped. And the TTL just a mechanism to forbidden the scenario that the packet will forwarding forever. That's after 255 hops away, then this packet will be dropped to minus the bad effect of the loop. Okay, this is the TTL value and how it is used. And then the protocol field. The protocol field, just like in the Ether frame. In the Ether frame, there are three fields: destination MAC address, source MAC address, and then the type. The type is used to figure out what is the data path carried. Okay, what is the protocol carried in data path? And the protocol also figured out what is carried in the layer 4, data. Okay, maybe it's TCP, maybe it's UDP, or maybe it's ICMP. The value figure out. If the value is 0, just figure out the data is an ICMP. If the value is 6, just means it's a TCP. If the value is, of course, this is hexadecimal. That's it. That's the 1 hexadecimal. Just in the decimal, it's 7. Okay. If the value is 7, just means the data carried in IP packet is a UDP. Okay, it's a UDP. Okay, the protocol field. And then we reach the end. Okay, and there's 3 questions. Okay, we just see these 3 questions. What is the IP subnet mask used for? IP subnet mask used for separate the IP address into 2 parts. Okay, the IP address is 32-bit long. Use IP subnet mask, we can separate the IP address into 2 parts. One part is the network part. Okay, one part is the network part, and another part is the host part. Okay, Okay, this is the usage of IP subnet mask. In Class A, Class B, and Class C have a default network mask. And use the IP subnet mask, we can develop another mechanism we call VLSM. Okay, variable length subnet mask. Okay. Then the second question is, what is the purpose of TTL field in the IP header? In the IP header, there is a TTL value. The TTL field is the time to live. This value will reduce when the packet reduced by 1 when the packet passing through one router. Okay, that's one to prevent when the network is looped, then the packet will forwarding forever in the network. But if there is a TTL value, then the packet will not forwarding forever in the network, will drop after 255 hops away. Okay. How are gateways used in IP network? Yeah, we know in the computer there is an IP address. The IP address is divided into network part and host part. And the computers can only communicate with other computer that has the same network part. That's the in one network. But if the computer wants to communicate with the other host with different network parts, should forwarding to the gateway. Okay, should first forwarding to gateway. Okay, this is another network. So first should forwarding to gateway, and this is the function of the gateway. Gateway just to as the exit point of one network. Okay, and using the gateway, one network can connect to other different networks. Okay.